All right. So we are in the Algebra 1 class on Khan Academy, going down to Unit 14, Quadratic Functions and Equations. And today, going to look at quadratic word problems in factored form. All right. So this question says, Amir stands on a balcony and throws a ball to his dog, who is at ground level. So I'm going to try to draw pictures for all these. The ball's height in meters above the ground, x seconds after Amir threw it, is modeled by this function. Okay. So what I'm going to do, I'm going to draw an x and y axis. The x-axis is measuring time in seconds. So as I move from left to right, time is passing, and that's the x value. And then the y value here is height. H of x is the height. The height is a function of x, which is time. So it depends on how much time has passed. If you know how much time has passed, this equation will tell you how high the ball is. The question is asking, what is the maximum height of the ball? So I don't know exactly where the ball is being thrown off from, but I think the idea is that it's falling. This is a quadratic function. When you multiply these x's together, you'll get an x squared, and the term's going to be negative. That negative sign in front is telling me that it's going to be a negative quadratic. So what it's going to look like, I know it's going to vaguely look like a downward U shape. So that's maybe not the perfect idea there. Let's say it's something like that. So at some point, it's going to hit the ground. This is the balcony that Amir is standing on. So Amir is right here. That's Amir. I will not draw him. So he throws the ball. And the question is, when is the ball at its peak? So in order to answer this, I'm going to try to figure out where is the vertex of this quadratic function. If I can figure out where the vertex is positioned, if I can figure out the x value of the vertex, I could plug that in and I could figure out the height. I could figure out, what is the max height. It's going to be at the vertex of any quadratic function. So to do that, I'm going to try to figure out where's the middle of this graph. So because the function is given in factored form, it actually makes the middle pretty easy to find, because what it gives you is the zeros of the function. It gives you the x values for which the height is 0. It gives you the x values for which the height is 0. And how many seconds, after how much time, will the height be 0? One of those times is 7. And I know that because I'm looking at the factor x minus 7. So if I plug in 7 for x, this will come out to 0. If I plug in 7 for x, the last factor will come out to 0. So 7 is one of the zeros. So I'll put that right here when time is 7. So I'll say x equals 7. And also when x equals negative 1, because I can plug in negative 1 here for x, and this factor will come out to 0. So negative 1. So this is x equals negative 1. So now kind of more accurately, I know that my quadratic kind of hits at those 2 points, negative 1 and positive 7. So if I'm trying to find the middle of that, the exact middle of negative 1 and positive 7, that's where the vertex is going to be, because all quadratics are balanced on the left and right. So the middle of this, there's a distance of 8. So the middle is going to be 4. 1, 2, 3, 4. That's going to take me to 3. So if I'm at 3, I know that's the middle because it's 4 away from 7, and it's also 4 away from negative 1. So the middle is going to be when x equals 3. So that means that when 3 seconds has passed, the ball will be at its peak. How high will the ball be after 3 seconds? This function will tell us. So you can plug in 3 for x. So to find the height when the time is 3, you're finding h of 3. That's going to be negative. It starts with a negative. And then x plus 1. So 3 plus 1 is 4. And then x minus 7. And 3 minus 7 is negative 4. So this is going to come out, this is negative 16. But then it's made negative again. So it's going to flip the sign. So the height's going to be 16. Positive 16. So that's our answer here. We got a height of positive 16. I know that the peak will be when x is 3, because that's the middle of this quadratic graph. I know it's the middle because it's halfway in between the x-intercepts of negative 1 and positive 7. All right, let's take a look at some more. We should probably check it first. So I say 16. Very nice. All right, let's take a look at this one. This one says an object is launched from a platform. So it's the same concept as the last one. Its height in meters in X seconds after the launch is modeled by. So it's the same exact concept as the last one. Is it asking the same thing? What is the height of the object at the time of launch? So if we think of it again, and here are zeros, you can already see them. You'll see the pattern. The zeros are 9, so positive 9, and then negative 1. So I know that's where the zeros are. The middle there, if I'm already kind of getting ahead, I'm not even going to need this, but the middle, the distance is 10, so I need to go 5 away. So 1, 2, 3, 4, 5. So it's going to be at 4. So I know that this quadratic peaks at 4 and hits the x-axis at -1 and positive 9. So if I want to find the maximum height, I could plug in 4 for x. But the question doesn't ask that. The question's asking, what is the height of the object at the time of the launch? So if this is launched from a platform, the platform is up here. So this part of the graph isn't even really happening. This is the start at the platform. So when we start, the time is 0. T equals 0, but I won't say t, I'll say x. X equals 0. So when x is 0, when the time has not really started yet, like the second the object is launched, how high is the object? All you need to do is plug in 0 for x. So we're going to plug in 0 for x, and the equation will tell us the height, because this is the height as a function of x. If I know the time, it will tell me the height. So I'm going to find h of 0. It's going to be -5 times 0 plus 1 is 1, and 0 minus 9 is -9. These two negative signs will cancel out to be positive, and I'm going to get 9 times 5 essentially, which is 45. So when the time is 0, the height is 45. That means that when we have not even started yet, when we're at the platform, we're already 45 meters in the air. All right, next question. All right, this one says Guillermo is a professional deep water free diver. His altitude in meters relative to sea level, X seconds after diving, is modeled by. Okay, so this is still a quadratic function. We're going to have an x times an x that's going to give us an x squared. Looking at this, there's a couple things I can think about. So I'm diving now. So I think what's going to happen, and I'll tell you kind of how I know, I see this is going to have a positive leading coefficient. There's no that when I multiply the 1 over 20 x times x, I'm going to get a positive x squared. So the graph is going to open upwards. So this is a diver that's going down. They're going to bottom out and they're going to come back up. So where is this going to happen? So if I think of the zeros of the graph, you might have noticed that one of them is 100. So I can go all the way over to 100, and maybe that's the point where they've come back up. And the other 0, I can actually plug in 0 for this x, and the height will be 0. G of x will come out to 0. If I plug in 0 for x, the whole function, like the value of the function, will be 0. So 0 is another one of the zeros, for lack of a better word. So when x is 0 and when x is 100, the function will be at 0. That means that I will be at sea level. I'll be 0 feet away from sea level, because you're measuring the y-axis is the distance from sea level. That's what y is, which is g of x. Y equals g of x. So what this means, if I know my zeros are at 0 and 100, I know that the middle of this quadratic, because I know it's going to be a quadratic, the middle is going to be when x equals 50. That's going to split the graph in half. So if it splits a quadratic in half, I know that that's going to be the minimum point. So the diver's going to bottom out when x is 50. The diver's going to bottom out at 50 seconds. I know this because they're following a quadratic graph that has zeros at 0 and 100, and the middle of that is 50. So that's where the middle of the graph is going to be. That's where the vertex will be. So what I'm going to do is I'm going to plug in 50 for x and see what I get, because if I know, same as the first two, if I know the time, I know the height. This one is just like a negative height because it's underwater. So I'm going to plug in 50. So it's going to be 1 over 20 times 50 times 50 minus 100, which is negative 50. So this is going to give me, and I am going to use a calculator on this. Let me stop here. So it's going to give me, it's going to be 50 squared. So 50 times 50, but it's going to be negative. 50 times 50. We know the answer is going to be negative anyway because they're underwater. So 50 times 50, but then that's divided by 20. So we'll divide that by 20. That's the same as multiplying by 1 over 20. So it's going to be 125. So the depth is negative 125, and I just realized it's not even asking that. It asks how many seconds after diving will Guillermo be at the lowest altitude. That is at 50 seconds. We now know the depth will be negative 125, but it didn't ask that. So I think our answer would be 50. If it did ask, now you know how to do it. All right, next one. All right. A hovercraft takes off from a platform. Its height in meters, x seconds after takeoff, is modeled by. This quadratic is going to be negative. I have that negative sign here. I have my x and my x, but then it's going to be multiplied by this negative. So the hovercraft's going to go up and it's going to come down. X is still time. Y is the height. The height is a function of time, h of x. That's y. How many seconds after takeoff will the hovercraft land on the ground? So it's not the peak. It's not asking the peak. It's not asking the takeoff. It's asking when it's going to hit the ground. So we know that we can find that out just by looking at the equation. The equation tells us there are two zeros here that I can see visibly because it's in factored form. So one of them is 11. That's going to be our answer is 11. Positive 11. So when x equals 11, the height is 0. When x equals negative 3, the height is also 0. But it's asking how many seconds after takeoff will it hit the ground. So if it's kind of following this path, this is our answer of when it hits the ground. So it should be after 11 seconds. All right. So hopefully that helps. And yeah, have fun with these.